Today we're going to look at how to solve more problems using the normal distribution model and the z-table. So we're going to look at several examples. The first one is a baseball example. Suppose that the Kansas City Royals pitcher throws his fastball with a mean velocity of 94 miles per hour and a standard deviation of 2 miles per hour. And the distribution of his fastballs can be modeled by a normal distribution. About what proportion of his fastballs will travel over 100 miles an hour? Now, there are several things that we want to look at in this problem. The first thing that we notice is that this is a normal distribution model. And the way that we know that is because the problem says that it's normally distributed. This means that we can use our normal distribution curve and our z-table in order to find the proportion that we're looking for. So we need a couple of pieces of information. The first thing we're going to need is the mean. The mean can be identified by several words. It can be called the mean, which it does in this case, or the problem could be asked, could give you the information on the average. There are several different types of ways that the mean velocity could be identified. So in this case, the mean is 94 miles per hour. The next thing that we're going to look for is the standard deviation. In this case, we have a standard deviation of 2 miles per hour, which means we know that the Kansas City Royals pitcher, on average, his fastballs go about 94 miles per hour, but sometimes they're a little faster, sometimes they're a little bit slower. And that variation can be described by about 2 miles per hour, sometimes slower, sometimes faster. We want to know about what proportion or what percent of his fastballs go more than about 100 miles per hour. So that 100 is going to be our x value. One of the easiest ways to solve this problem is by drawing a graph. We know it's normally distributed, so we can draw our normal distribution curve, putting the center of the curve at 94 miles per hour. That's about half of his balls go faster than 94 and half of his balls go a little slower than 94. We want to know what percent go faster than 100 miles per hour. 100 on this graph would be bigger than 94, so we're just going to estimate where it goes. And since we're looking for those that go over that, those that are faster than 100 miles per hour, we're going to shade to the right. If we wanted to know the proportion that were slower, we would shade to the left. One thing we notice is that the balls that go slower than 100 miles per hour, way more than half of his fastballs. So this value, the percentage of fastballs that go more than 100 miles per hour, that's not going to be a very large percentage. Well, how are we going to find that? The only tool we have at our disposal is our z-table. But in order to use our z-table or our standard normal probability tables, the fastballs need to be represented as standardized values. The only way to do that is using our conversion formula, z equals x minus mean divided by standard deviation. In order to use this formula, we must have 3 out of these 4 values. Well, look, that's exactly what we have. We have the mean, we have the x, and we have the standard deviation. So to calculate our standardized value, all we do is substitute in each of the numbers in the place that they go. X is 100, the mean is 94, and the standard deviation is 2. Carrying through this computation, 100 minus 94 is 6. 6 divided by 2 is 3. Since this is a standardized value, a z-score, this value has to have 3 digits in order to look it up on our table. So we're going to add 2 zeros and a decimal point after the 3. And now this is our 3 digits, 1 digit before the decimal point and 2 digits after the decimal point, that will allow us to look it up on our z-table. So we're going to look up the value 3.00 on our z-table and find the proportion. Well, our z-table has 2 sides. It has a positive side represented by the positive values. Let's switch over to the positive values. The positive values of our z, and then it also has a negative side, which is represented by the negative values of z. So we're going to look on the positive side since the z value we're looking for is a positive number. The first 2 digits, the digit before the decimal point, and the first digit after the decimal point are in the left-hand column. So on our z-table, we're going to be looking down the left column for the digits 3.0. Then across the top of the table, we're going to look at column 0. So going down the left side of the table, we find 3.0 is pretty far down the table. And then column 0 is the first column. When we trace down the 0 column and across the 3.0 column, we find a 4-digit decimal. This decimal is our proportion. That's the proportion we're looking for. So the proportion is 0.9987. Now remember that this is also a percentage, because in statistics, the percentage and the proportion mean about the same thing. So this is 99.87%. But what is it 0.9987% of? Well, it's 99.87% of the area under the curve. But which area is it? The shaded side or the unshaded side? Well, this is way more than 50%, so just logically we can see that it's going to be the unshaded area. But that wasn't the question that was being asked. We wanted to know the proportion of fastballs that went more than 100 miles per hour. So we're looking for this space on the other side. Well, knowing that the entire area under the curve is 100%, it's 100% of the area, if we take 99.87% away from that, we end up with the unshaded area 99.87%, and the shaded area is 0.0013, or about 0.13%, a pretty small area. Now on the AP exam, it's important that we answer the questions in context. We don't just want to leave that decimal as our answer. So the question, remember, was what proportion of his fastballs went over 100 miles per hour? The answer, the proportion of fastballs over 100 miles per hour is 0.0013. And that's how you do it. Thank you. For this next question, we are still talking about, let's just go back to the original question. We're still talking about the Kansas City Royals pitcher and his fastballs. So for part B, we still have the same mean velocity of fastballs, meaning that about half of his fastballs go more than 94 miles per hour, and about half go slower than 94 miles per hour, and a standard deviation of 2, and the distribution is still modeled with the normal distribution. So for this question, we're looking for the proportion of his fastballs that go slower or less than 90 miles per hour. Let's go ahead and draw a graph based on everything we know. Well, what do we know? Well, we know that his mean fastballs, so on average his fastballs go about 94 miles per hour, but they vary about 2 miles per hour, some faster, some slower. We want to know what proportion of all the fastballs that he throws go slower than 90 miles per hour. So that 90 miles per hour is going to be our x value. And just like last time, we want to draw a graph to kind of figure out what's going on in the problem. We know on average they go about 94, but 90 is smaller than 94. How much smaller? Well, we don't know. That's what we're going to find out. Less than indicates that we're going to shade to the left of that 90. Well, the 90 is not a standardized value, so we can't look the 90 up on our z-table. But we have a conversion formula that would allow us to use our z-table. What's the conversion formula? Well, that's our z formula. X minus mean divided by standard deviation. Substituting in the values, we have our x value is 90, our mean is 94, and our standard deviation is 2. When we calculate that, that's going to be our z value, the value we can look up on our z-table. Be really careful of the negatives and positives here because they're important. It determines which side of the table you're going to use. So in this case, when we calculate 90 minus 94, we end up with negative 4 over 2, which is negative 2. Remember, this is a z value, so it has to have 3 digits, so we'll add 2 zeros onto the end. Now we're going to be on the negative side of our z-table because the z-score came out to be a negative number. So just like we did before, we're going to look down the left-hand column of our z-table. We find negative 2.0 and over to column 0. And what we find is we find the decimal, which represents the proportion that we're looking for. So that's 0.0228. So the proportion is 0.0228. Remember, the proportion is always going to be a 4-digit decimal. So this represents, moving the decimal 2 places to the right, 2.28%. Well, what's a 2.28% of? What's 2.28% of his fastballs that go slower than 90 miles per hour? That is what we're looking for in the question. One thing that we're going to notice is that the values from the table are always the proportion that are to the left of the value on the x-axis. So in this case, it represents the proportion of fastballs that are slower or less than 90 miles per hour. Remember that we have to write this in context on the AP exam. So we want to answer the question. What question was being asked? What proportion of his fastballs go less than 90 miles per hour? The answer, the proportion of fastballs that are slower, and we can use the words right from the problem, that are less than 90 miles per hour is, and you can use either one of these values, I like to use the decimal, 0.0228. And that's how you work this problem. Thank you. In part C, we're still using the same information that we saw in point A, where we're looking at the Kansas City Royal fastballs that had an average pitch velocity of 94 miles an hour and a standard deviation of 2 miles per hour. But this time, we're looking for proportion of fastballs that are between two numbers. Now for this problem, we still need to know the mean, 94, and we still need to know the standard deviation, which is 2. But because we're looking for a proportion that is between two numbers, 93 and 95, representing the proportion of pitches that go faster than 93 but slower than 95 miles per hour, we would shade between two numbers. So for this type of problem, we actually have two x values, which means that we're going to be using our standardized formula for z. We're actually going to be using it 2 times. One time to find the standardized value for 93 miles per hour, and we do this the same way that we did all the other problems for z, as you subtract the x value minus the mean divided by the standard deviation, keeping in mind that this problem is going to be negative. It's going to have a negative z value. We expected that because the 93 was smaller than the average. And negative 1/2 is negative 0.50. And if you're not sure about that, then you can always just use your calculator to figure that value out. So the first proportion that we're going to find is on the negative side of the chart. So we go over to our negative side. We have to look really far down the chart in order to find negative 0.5. Since it's negative 0.50, we look across the top to column 0, where the two numbers meet is the proportion we're looking for, 0.3085. That's the first proportion. The second proportion is going to come from our other x value, the x value on this side, which is 95. We're going to use the mean again and the standard deviation again. And this time we're going to use an x value of 95. So calculating the z value, same formula, but this time we would expect a positive z value since 95 is to the right of the mean. 95 minus 94 is 1. 1 divided by 2 is positive 0.50. So looking at the standard normal probabilities table, we look down the left column. We don't have to go very far. Down to 0.5, over to column 0, and we end up with a z, a proportion of 69.15%. We're going to take these two values and we're going to subtract them. We're going to subtract the larger number minus the smaller number. So we have 69.15, because it's the biggest, minus 3085, and we subtract. Now, you want to make sure when you do this subtraction that you carry it through correctly. So you might want to use your calculator for this. So when you take out your calculator and you subtract 0.6915 minus 0.3085, we get our proportion. Don't forget it has to be 4 digits. 3830, which is what you get when you subtract 6915 and 385. Now, what does this 0.3830 represent? Well, it represents 38.3% or 30% of the fastballs that are between 93 miles per hour and 95 miles per hour. Answering the question in context. The question, you can use the same words that they used to ask the question. The proportion of fastballs that travel between 93 to 95 miles per hour is, and you can either use the decimal or the percentage. I think this time we'll use the percentage, 38.3%. And that's how you work a between problem.